In this video, we're going to take a look at the cylindrical shells method, but rather than rotating around the y-axis, we are now going to rotate around the x-axis. So the only difference is when we're rotating around the x-axis, we have to have our functions as functions of y. And so we've done this before in other lessons where we have our functions x as a function of y rather than y as a function of x. So we are given a function g of y is equal to 2 radical y. And on the y-axis, our bounds are 0 to 4. And we are revolving around the x-axis. So as always, draw yourself a little picture. So we have the x-axis is our axis of rotation. Here is our function, and we're bounded by 4, and we're bounded by 0. So remember what I told you to do in the last video is always draw a rectangle. Now here's where it's important, because the rectangle now is going to be sideways. When we are rotating around the x-axis, remember I said the length of the rectangle, let's do that in a different color. The length of the rectangle must be parallel to the axis of rotation. So if you're not sure whether it should be a function of x or a function of y, you say, ooh, my rectangle is parallel to the axis of rotation, which is x. That means it's going to have to be a function of y. So first thing we want to look at are our bounds. The bounds are given to us from 0 to 4. The radius of the rectangle is going to be, in this particular case, a y value from the rectangle to the x-axis. That is a y value. So the radius is y. And the height of the rectangle, as always, from the y-axis to the actual function is the function value. So really there's nothing that's different other than we're rotating around a different axis, and so we have our function as x in terms of y. Everything else is going to be pretty much the same. Put this all together in our integration problem. You have your 2 pi, y is your radius, 2 radical y is your height times dy. Simplify that to get y to the 3 halves. Bring out the 2 pi, the 2 and the 2 gives you a 4 times the pi. Find the antiderivative and evaluate it. And there you go. So a fairly straightforward rotating around the x-axis problem. Now, what becomes a little bit more challenging, just like we did with the disc and the washer method, is when you are rotating around a line that is not the x or the y-axis. This is where it tends to get just a little bit confusing. So we have a lot of variables that we need to be thinking about here. Mostly the 3 things that we need to be thinking about, of course, are these things. And so this is why I like to spell out the bounds, the radius, and the height. If you get each one of those correct, then you should be able to put together your integral correctly, and then you should be able to integrate and get the correct answer. So first of all, you draw a little graph. Function value is just x, so that's just a straight line. And so the bounds of integration on the x-axis are from 1 to 2. And if I draw myself in a little rectangle there, it is going to be parallel. The rectangle has to be parallel to the axis of rotation, which is x equals -1, which is right here. So x equals -1 is a vertical line at -1. My little rectangle, the height is parallel to it. We're going to rotate that around. So the bounds of integration are from 1 to 2. That just comes from here. The area that we're looking at is from 1 to 2. The radius, this is the part that's a little bit different. The radius is not simply x. So you have to think about this very carefully now. All right. So the radius, let me get rid of some of this other stuff here. The radius is going to be the distance from my rectangle to the line. It's going to be this distance right here. That is my radius. Well, this distance, let's break it down. This distance right here is x. This distance over here, well, the absolute value of the distance is a 1. And so you have your distance x plus a distance in the other direction of 1. And again, you can think of that x minus a negative 1, because remember, you generally subtract them. X minus a negative 1 is x plus 1. So this is x, this is 1. The total distance is x plus 1. That's the tricky part. And the height, once again, is just the function value. So once you've got that, just put it all together in your integral. 2 pi, there's your radius, there's your height. Simplify it, find the antiderivative, and there's your answer. So once again, the tricky part for this problem, for any problem when you're rotating around something that is not the x or the y-axis, is usually going to be finding the radius. Be very, very careful about finding the radius. If you have two different functions, as we did in a previous problem, then you have to be careful about the height, right? And this problem, use the method of cylindrical shells to find the volume generated by rotating the region bounded by these curves about x equals 2. All right, so this has got a little bit of everything in it. All right, so we have to alter the radius, we have to alter the height. So let's just take it step by step. The first thing you always want to do is draw your graph. Use Desmos. And so this is pretty much what my cross-sectional area would look like. And the bounds are from 2 to 4. That's just spelled out for us here. Bounds are from 2 to 4. Now, you need to find those bounds. You're not given the bounds, but the bounds are the points of based on the points of intersection, which you can get from Desmos, or you can find algebraically, very simply, setting the two equations equal to each other, and you're going to end up with 2 and 4. Secondly, the radius. So we're looking for the radius of the rectangle. So here's my rectangle. We're rotating it around 2. Here's 2. How far apart are they? All right, so how far apart are they? Here is the x-axis right here. That's the x-axis. So the distance, this distance here is a distance x. From the x-axis to the little rectangle is a distance of x. And then the distance from the x-axis to the line x equals 2 is a distance of 2. So what is the distance between these? It's going to be x minus 2. And then finally, the height of the rectangle will be obtained. The height of that rectangle is going to be the difference between the two function values. You've got the top function is 6 minus x squared, and the bottom function is the function 8. So you just take 6x minus x squared minus 8. And that gives you the height of the rectangle. So again, it's very, very important. Identify your bounds, identify the radius, identify the height, and then just stick it all in your integral and go to town on it. All right. So this is a little bit more work because you have to do some algebra here. You have to multiply the x minus 2 times that. So you're multiplying a binomial times a trinomial. So you get this long string of terms. Just be careful. A common mistake is just accidentally multiplying or adding wrong or getting a sign error. So be real careful with that. Combine some terms. I skipped a few steps here because I was running out of room. So I didn't actually show any integration, but you guys know how to do that. Simplified it here, find the antiderivative of all these terms, evaluate it, and you get 8 pi over 3. All right, one more. Now, a region bounded by the graphs of two functions. We've actually already done one like this. So we're going to do another one. And this is not example 5. It should be what, number 8. So we have two functions. We have the function square root of x, and we have 1 over x. And so I'm going to create a little rectangle, a vertical, right there, parallel to the axis of rotation, which is y. So the bounds of integration. Well, the bounds of integration, it tells me that what they are right there. It's 1 to 4. The radius, well, it's pretty straightforward. That's just going to be x. And the height is just like we did in the last problem. It's going to be the difference between the two functions. You have to know which function is on top, which function is on the bottom. Square root of x is on top. 1 minus x is on the bottom. So it's the square root of x minus 1 over x. So getting a good picture is very, very important. Making sure you understand the picture, making sure you understand what you're rotating around, draw your little rectangle on there, then find these three guys right there, and then the rest is easy. So from here, you have 2 pi, you have your radius, you have your height, bring the 2 pi out, multiply this stuff together to get x to the 3 halves minus 1, finding the antiderivative of that, evaluating it from 4 to 1, and we get volume is 94 pi over 5. All right, I believe that is the last problem. So this set of video notes only has a part 1 and a part 2. Most of them are going to have 3 parts, depending on how long the videos are getting. I don't like them to be too much more than about 15, 20 minutes at the most. All right, have fun with the homework.